You know, all around us, there's this invisible force constantly at work. It grinds down entire mountains, it carves out massive landscapes, and it does it all in complete silence. It's patient, it's powerful, and it is absolutely relentless. Today, we're going to pull back the curtain on this silent sculptor, rock weathering.
So let's start with this question, because it really gets to the heart of it, right? You look at some giant mountain, a peak of solid granite, and you think, that's permanent, that's forever. But it's not. Every single rock on our planet is locked in this slow, constant battle with the elements. And it's a battle that the rock will always, eventually, lose.
And the name for that process, for that losing battle, is weathering. It's basically the collection of forces that take big, solid rocks and start them on their journey to becoming small rocks, and then sand, and eventually soil. Now, it's really important to get this straight. This is not erosion. Erosion is when the broken pieces get carried away. Weathering is just the breakdown itself. It's the hammer, not the cleanup crew.
So how does this all work? Well, the first method is pretty much a direct mechanical assault. You can think of it as a brute force attack on the landscape. This is what we call physical weathering. And the key thing to get here is that the rock's basic chemistry, its identity, doesn't change one bit. A chunk of granite that gets broken apart by physical weathering is, well, it's still granite. It's just a smaller piece of granite. Think of it like this. If you smash a dinner plate on the floor, you just end up with smaller pieces of the same plate. That's physical weathering.
And one of the most powerful forms of this is something called frost wedging. It is like a cosmic crowbar. So water seeps into a tiny little crack in a rock. Then it freezes. When water freezes, it expands with incredible force. Now, one little freeze-thaw cycle isn't going to do much, but when that happens day after day, year after year, that relentless pressure can split massive boulders wide open.
And hey, frost isn't the only physical force out there. You've got thermal stress. That's when rocks expand in the scorching heat of day and then shrink in the cold at night, over and over until they crack under the strain. Then there's abrasion, which is basically nature's sandpaper. Wind and water just blasting rocks with tiny particles, grinding them down. And you even have exfoliation, where huge outer layers of rock just peel off like the skin of an onion.
Okay, so breaking rocks apart isn't always about brute force. Sometimes the attack is way quieter, a little more insidious. It's happening at a molecular level. Welcome to the chemical meltdown.
Right, so if physical weathering is like smashing that plate, chemical weathering is like dissolving it in acid. The very substance of the rock is altered. It actually reacts with its environment and transforms into something totally new, and almost always something much, much weaker. And there are a few main culprits behind this kind of chemical attack. First, you've got carbonation. This is where slightly acidic rainwater literally dissolves certain rocks like limestone. Then there's oxidation, which, is just a fancy word for rusting. This one targets rocks that are rich in iron, turning them that classic reddish color and making them crumble apart. And finally, there's hydrolysis, where water itself reacts with minerals inside the rock to form totally new, softer materials like clay.
All right, so we've seen rocks get shattered by sheer force and dissolved by chemistry. But there is a third player in this game, and it's a surprising one: life itself. This is biological weathering.
Yep, life finds a way to break down rocks. A tiny little seed can fall into a crack, and as its roots grow, they expand with the same relentless power as freezing ice. You've got burrowing animals that churn up the ground, exposing new rock surfaces to attack. And get this, even tiny organisms like lichens produce acids that slowly but surely eat away at the very rock they're living on. It's a real team effort.
Okay, so we have these three powerful forces: physical, chemical, and biological. But what decides which one is going to dominate in any given place? What dictates the rules of the game? Well, it turns out there's a set of master controls that dictate the speed and style of weathering everywhere on Earth.
The fate of any given rock really comes down to just a few key factors. Climate is king. Temperature and rainfall pretty much set the whole stage. Of course, the rock type itself matters a ton. Some minerals are super tough, while others dissolve really easily. And naturally, the constant presence of water and air, that's the fuel that powers this whole engine. And you can see this play out so perfectly when you look at different climates. Go to a hot, wet rainforest, and chemical reactions are just supercharged. Rocks there essentially just rot away. But then, travel to a cold, moist mountain range, and physical weathering completely takes over, with frost wedging splitting those rocks apart. It's the same planet, just completely different styles of destruction based on the climate.
But here's the thing, and this is probably the most important takeaway of all. We've spent all this time talking about breaking things down, about destruction. But that's really only half the story. Weathering isn't an end, it's a beginning. Every single grain of soil on this planet started out as solid rock, broken down by these very forces we've been talking about. Without weathering, there is no soil. And without soil, there's no life as we know it.
So the next time you see a crack in the sidewalk or a rock that's kind of a rusty color, just remember the immense, silent power you're actually witnessing. It's a force that has shaped our entire past and is actively, right now, sculpting our future. Which leads us with one last thought to chew on. What new landscapes are being carved out as we speak, for a world we can only begin to imagine?